In this video, we're going to talk about expected value. Now, we're going to do a question first, and then we're going to go through all the definitions and things like that. So, the question we're going to do, it's a game. The game is simple. We're going to spin this wheel. Now, if it lands in the lose section, you lose. If it lands here, you get to try again. And if it lands here, you win the big prize. Now, it costs $1 to play the game. And obviously, if you lose, you get no money. You've lost $1 essentially, so you get $0 there. Now, if you get a try again, that's like you get your dollar back, and you can choose whether you want to give them the dollar and have another go. So that's $1 there. And finally, if you win, this is the big one, you get $10. Now, the probabilities of each of these happening here. Now, the probability of losing is a 50% chance. The probability of try again, you can't see it from the diagram, but I'm going to tell you it's 40%. And the probability of winning is obviously whatever's left over, which is 10%. Now, all of this could be asked in a question that was a bit more wordy. So there's our question in words rather than this weird little diagram I've drawn. And the question that this video is all about is this one. What is the expected value of playing this game? Every time you play this game, how much money would you expect to make on average? We're actually finding a kind of average. Now, we're going to create a bit of a table here, a probability distribution table. Here's my distribution table, and it's a little bit different to the ones that you've seen in the past. So there are three options: lose, try again, or win. Now, when I lose, I paid $1 to play the game. So the thing that's happening is I'm losing $1, minus $1. Now the probability that I lose $1 is 0.5. Now try again. That means that I didn't win any money and I didn't lose any money because I paid $1 to play and then they gave me the dollar back. So that's a 0. And the probability of getting a 0 or $0 is 0.4. And finally, when I win, well, I paid $1 to play and I win $10. So that means that I'm getting $9, right? So a 9 there. And that's 0.1. Now, you need to be careful with this -1 and 9 because some people put like a 0 there and a 10 there. But you need to take the net of what you paid to play the game and what you got back. All right, and finally, we're going to find our expected value. So the capital letter E for expected value of X. The expected value of this random distribution is going to be equal to, now, 50% of the time we lose $1. So 0.5 times -1, losing $1. Plus 40% of the time we get 0. So 0.4 times 0 plus 10% of the time we get $9. You can see what I'm doing here. I'm multiplying this by this, multiplying this by this, multiplying this by this, and adding them all together. When I do that, I'm going to get a number. Now my answer here is 0.4. Now, what on earth does 0.4 mean in this circumstance? Well, let me put it in a sentence here. In the long term, you would expect to average a 40-cent profit every time you play this game. In the long term, right? Because on any single game of this, you don't make 40 cents. You either lose $1 or lose no dollars or win $9. But over the long term, if you played 100 of these games, then you would expect to make 100 times 40 cents. You would expect to make about $40 if you played this game 100 times. That's what expected value is. It's very, very useful for making decisions about whether you should do something or not. If something has a positive expected value, then you should probably do it. If something has a negative expected value, then you probably shouldn't. A little bit of formal stuff here. The expected value, EX, is the long run average of the random variable X. Sometimes instead of EX, we write mu instead. This is that Greek letter mu, which we generally use for averages. You've got a couple of like different ways that you can express this formula. We can say that the expected value is equal to sigma, the sum of x times this probability that x is equal to x, which is what we've been doing here. The sum of this times this, this times this, this times this. That's what that says in mathematical notation. You'll see it on your formula sheet here as sum pi xi, where pi denotes each probability value and xi denotes each x value. But again, it's the same thing. It just says take each probability in x and multiply them by each other and take the sum of all of those. I think it's easier to just remember how to do it rather than trying to interpret these formulas. So that's expected value. As usual, the goal here is to practice this as much as possible so you can get really good at it. Good luck.